Hello.
Hello, sir.
Yeah.
Yes, sir, you are audible.
I'm
Yes, sir.
No. Yeah. So, mm, good. So tell me, how are you guys doing? Hello. Yeah. So, did you guys go over the this lecture, this video, this slides? Hello.
Yes, sir, we did.
I mean, maybe. I mean, how many of you have done? I mean, I really need to know these things. Just one second. Let me just quickly have a poll, maybe. So there were two slides, right? If I'm not mistaken. Yeah. Just one second. Yeah. So let me just start. Start this thing with starting this poll. To be kind of help you to understand what all things have you guys. Okay, I think I basically got the idea. So this experiment has completely failed. So number of people who have actually gone over these slides seems to be like not at all a good percentage. Now, I mean, this is for particularly addressed to this question that I'm asking now is particularly addressed to the people who have not gone over, say, slide 5B, okay, or we just went over it partially. Why didn't you go over it? I mean, can you just unmute yourself and say why? Is it like that you guys were just, I mean, too busy with other things, or you found this 5A hard, or you found it to be very easy? I mean, please unmute yourself and just let me know. Hello. See, if I don't get any response from you guys, I am going to call out individual people's name and then ask you. It will be very not be the most perfect thing.
Sir, I'm Auditro. May I speak something?
Yeah.
I know something about 5B, like infinitude of primes. There are infinite number of primes. I can do proofs by using contradiction
Yeah.
of this thing. I know something, but not entirely. I know few things there.
Did you go over it or not?
Go over, but not thorough manner.
Well, that's fine. Okay. So,
I know
okay.
some things there.
What about the rest?
Sir, I have gone through the first, and in second, I have faced 2, 3
Doubts.
doubts,
Okay, very good. So I will come to that. I mean, please.
but I have gone through that.
Okay, that's excellent. I mean, that is exactly the reason why we have this class to kind of clarify your doubts. Okay.
Yes, sir, and that helped in my assignments.
Okay, very good. But okay, what about the others? I mean, particularly the people who have not gone over it. Can somebody please, or plan you guys please unmute yourself and say that, see, sir, I have not gone over it, and this is the reason.
Hello, sir.
Yeah.
Yes, sir, I have not gone over the slides because I am doing this LaTeX homework in the discrete mathematics, which is hard for me because it is initially that I have too much problem with the syntax. So basically, I'm doing that assignments. So that's why, and there is a Python program which I am doing since I'm also new in programming, sir. So that my time is gone in that on doing that all the things, sir.
Okay, so the Python program is from which course actually?
Sir, C lab, computing lab.
Computer lab. So you are from the CS background or no? From the math background, is it?
Sir, I am from CS background, but sir, actually, in my college, I have not done that programming too much, sir.
Okay. You are from CS background, but you have not done programming earlier.
Yes, sir.
Okay. See the LaTeX thing. I mean, I someone maybe are you the person or somebody wrote to me today that can he submit his assignment in a handwritten format? So I told you no. The reason is that the LaTeX is a very trivial thing. So this is something that I cannot imagine that someone doing a MTech in CS can have a trouble. So there are these formats, there are these templates, copy the templates, and after that you basically the syntax are like, I mean, like, this is so obvious, there's nothing to be said. Yes. So I am not buying that argument that LaTeX is too hard or something.
No, sir. Actually, I am trying, sir. I have done so much work in the LaTeX, and I'm still doing my assignments, sir. Now I'm getting used to it, sir.
Okay. No, see, I mean, okay, good, fine. Okay, I understand that you have. So you are saying that you had less time, and that's why you could not do that, right? You would not go over it. Did you go over 5A?
No, sir.
So you're not going over 5A or 5B either.
Yes, sir. Yes, sir.
Okay. Okay. Who else have not gone over both 5A and 5B? God, this is not going to work. I think. Okay. Ashu Khodwal, can you please unmute yourself?
Yes, sir.
Yeah. Can you say so? Which?
Sir, I did 5A.
You have did 5A. You did not go over 5B. Hello.
No, sir.
Not at all.
Hello.
Hello. Can you hear me?
No, sir.
So why? I mean, did you find 5A to be hard?
Yes, sir.
You found 5A to be hard, is it?
Sir, I have also same problem.
No. What is the same problem?
No, sir.
Don't tell me same problem or not. I didn't understand. Which problem?
Sir, as Chhatra Pratap says,
Okay, so you say that you have so you had less time.
I have syntax problem in LaTeX, yeah.
Okay, so you are also MTech student. is it?
Yes.
And okay,
Yes, sir.
so LaTeX is what is stopping you guys from doing it. Is that what you're saying?
Yes, sir. I am also facing the problem. I have I have studied it, but facing.
Okay. I mean, hello. Uh,
Hello.
okay. So, fine. So there is a LaTeX problem. What about, so who else have a LaTeX problem? Who, particularly those who have not studied. I mean, LaTeX problem enough. See, of course, I have given you something to read or something to submit your assignments. So it will of course take time. Okay, I understand there are other courses in which things are going on. They also will take time. Okay, so I am not saying that LaTeX will not take any time. LaTeX will of course take time. But question is that does it take that much time that you cannot even read the slides? So go over the slides. And this is like a very basic kind of slides that we are talking about. Now I just am trying to understand. I mean, maybe in that case, all I have to do is I have to go over the slide in the class.
Hello, sir.
Yeah.
Sir,
Nikhil this side. Sir, actually, I have gone through 5B, but I am from computer science background and finding some proof very means I am not used to those proofs.
Okay, that is fine. We can talk about that. If you have gone over 5A or 5B and you have doubts, I will certainly go over it.
Yes, sir.
Okay, so there is no question. That is exactly what I will spend the whole
Okay.
time now on that.
Okay.
Okay. But I'm just trying to understand that. I mean, if the people are saying that, oh, I have not done 5A and 5B because of some issues about my I had less time or something like that, then I have to really understand what is the reason. I mean, should this process of asking you guys to read and then coming back and solving questions from that, is that a feasible solution? So that is basically okay. So maybe I don't know how to kind of get. Can you please identify whoever has not read 5A, the 5 of you? Can you unmute yourself? All 5 of you.
Hello.
Hello.
Yes, sir. I'm Ankit from MTech CS. Sir, actually, I have also not gone through this both the 5A and 5B. So the reason is same that actually this since this is the first time that I'm actually exposed to this LaTeX problem. But sir, actually, I think this will be only for the first time. Next time, if there will be any assignment, then I think it will not take much time doing the LaTeX because this time I have actually gone through all this syntax. And this is the first time I have faced some problems, but next time I think it will be pretty fast. So
Okay.
I think this is only for the first time. Next time it won't happen.
Okay.
Actually, it consumed a lot of time learning the syntax and stuff, but next time it won't happen.
Who else?
Sir, I am Somo. I am very sorry for this week. I was identified COVID-19 positive last week.
Okay.
So I go through a mental trauma and.
Oh, that's fine. Okay, I understand. Okay, if you have mentally, physically, health-wise problem, then of course that's okay.
I try to submit all those things for the coming week. But this week I am very mentally. I am going through some psychological trauma.
Sure.
Okay, so
You are also a MTech student or a PhD student?
GRFs, yes.
GRFs. Okay. Okay. Anybody else who has not even gone through 5A?
Hello, sir.
Yeah.
Yeah. Yes. I was gone through 5, but I'm difficult. It's getting difficult to understand everything. So I'm busy with assignment and it's taking time and consume my time. I'm like slow in understanding.
Okay. So you are also MTech student or a GRF student?
Yeah, I'm tech student.
MTech student. Okay. So, but you have gone over it but you could not understand all of it. That's what you're saying, right?
Yes. Only 5A.
Only 5A you have gone over, but not, okay, fine. Okay, so I realize that, so there are people who have gone over 5A and have not been able to understand all of it. So that's perfectly fine. Okay, and then there are some people who are basically are giving the excuse of the homework to say that they could not go over the slides. So unfortunately enough, I'm not buying that excuse that much. But yeah, if you don't understand it, completely understandable. Okay. Again, I'm saying it is not your job to understand certain things. I mean, it is of course your job, but if you don't understand, it is not your fault. I will try to ensure that you guys understand. Okay, but it is your job to put in the effort. If you don't put in the effort, I cannot do anything. That's just nothing that I can do. So I didn't find any non-trivial excuse for that. The only thing is that okay, there was a submission, the LaTeX submission, and they're using the excuse of LaTeX to say that you could not go over some slides. That I don't buy. Anyway, so now in that case, let me ask you guys so we will be spending the rest of the time, next 1 hour or so, just addressing your problems. So can you now say, whoever has any doubts, questions about this 5A or 5B or other stuff, can you please just tell me, and so that I can accordingly go over it.
Hello.
Hello, sir.
Yeah.
Sir, I have a doubt in one of your previous classes where you have studied the prime number. Means the question is like that: prove that a square of a prime number is always 1 mod 6 when the prime number is greater than equal to 5. Means prime number is greater than equal to 5.
Correct.
So, sir, can we prove it by other methods like can we use like a to the power n minus 1 is equal to 1 mod p, like this?
I think there are possible ways of doing it. Okay, so there are certainly a lot of other ways of doing it. So if you do something in a different way, that's perfectly acceptable. Okay, there's no doubt about that. Okay, so see, I'm giving you examples. So don't think of these problems as problems. These problems are more like an example to kind of go over these various proof techniques and all those things. Okay, so it is very much possible that one particular problem can be done in some other way. Okay, so if that is your problem, that I mean, do I insist that you have to do it this way? No, not necessarily.
Okay, sir.
Okay.
That I am asking, sir.
Yeah, that is perfectly fine. Okay. Like for example, I can deal with this one that in the 5B there is this statement of primes. You can see my screen, right? Hello.
Yes, sir. Yes, sir.
Yeah. Primes are infinite, right? So there are infinitely many primes.
Hello.
Yeah. Hello.
Sir, I have a doubt regarding the question in our assignment. That you have to prove that finitely the sum of finitely many rational numbers is finitely many irrational numbers is irrational.
Okay.
So, sir, in this proof, can we assume something?
That's what to say. Can you see this actual statement?
Yes. Distinct irrational numbers can never be irrational numbers. Finite sum of.
Did it say exactly to prove?
Prove or disprove?
Prove or disprove?
Yeah, yes, sir. Yes, sir. If I am just asking that, can we assume a general fact like the sum of one rational and one irrational number is irrational? Like this, can we assume?
Yeah, you can. I mean, you can assume. I mean, okay. I mean, it is true. So
okay, so we can assume that it is true, and based on that, we can go on further.
But okay, so I think the submission deadline is over, right? Maybe this is something also I should look at this one. When was submission deadline?
Thursday.
Huh?
Thursday.
Oh, it is on Thursday, right? It is not yet over. Fine, good. Okay, yes, so I don't want to comment on that. Yeah, fine.
So we can assume, or we have to prove the general facts also.
Okay, I mean, it is assignment. So if you want, you can write this proof also. Okay, so that is just another 2 lines. But that statement is a true statement that you're saying, and if you want, you can assume. If you want to assume it, you can assume it.
Okay, sir. Thank you.
So you.
Hello, sir.
Yeah.
Sir, actually there are several ways to prove statements. That is prove by contradiction, contrapositive, etc. So if we are using one such method, then do we have to mention it in our proof that final statement should be like this, that does it is proved by contradiction?
No, not necessarily. Okay, all I want is that you need to prove. So you have to write it properly. Okay. So I mean, if it is a proof by contradiction, it's a good idea to write that we will prove by contradiction and then prove it in this way. Okay. So at the end of the day, it should not be that I have to find out that what exactly that you have done.
For example, suppose I am using a proof by contradiction.
Yeah, it's better to write I prove it by contradiction.
So then I'm just in the last statement I'm using that since my assumption is false, hence it is proved to be true or false by contradiction.
Yeah, I mean it's like it's a style of writing. However you want to write, you can write it. Okay. So in that case, let us assume something else, right? I mean you have to write it in a proper way. It's about the presentation part, right? So if you want to prove, say A implies B. Okay, what is the proof by contradiction? Proof by contradiction is that not A, not B, and A is false. So, right, is false. So one way of doing it is that you can say one way says that we prove by contradiction. By contradiction. I mean, this is one way of writing. Okay. So, so let not B be true. Right, and you go proceed something, and then at the end of the day you see something. So you kind of from this you end up deducing that it is not A, which is not true, or some kind of stuff like that, or you get a contradiction out of it, right? You get a contradiction. I mean, all that you are asking me is that is it important to write this particular line? That's all that you are asking me, right?
Yes, sir.
I mean, does it really matter that much? I mean, it's a representational thing. I would write it, but if you think that no, you will pay a lot of hard work to write the statement, then don't write it.
Hello, sir.
Yeah.
Sir, there is a doubt regarding direct proofs.
Right, but just 1 second. That someone has asked me in the chat whether monotonically increasing means strictly increasing or not. Okay, so this is for the number of functions, right? If I'm not mistaken.
Yes, sir. The last one.
The number of functions from something, right?
Yes, sir. Yes, sir.
Yeah, so it is strictly increasing. Yeah. Okay, you assume it to be strictly increasing. Okay, I mean, if it is non-decreasing, then the problem becomes much more complicated. You can try it out, but
sir, but in general, if we say monotonically increasing, then it would mean strictly increasing, or it may have some stagnation in between.
I mean,
somewhere it is written that it may have, and somewhere it is written it should be strictly.
Yeah, see, there's nothing like that. There's no particular clarity over there. Okay, so if and when required, we should kind of maybe write it up much more formally.
Okay.
Here you can assume it is strictly increasing and can go ahead.
So can we assume non-decreasing as well?
You can assume non-decreasing and try to go ahead. That's a much harder job. Okay. Yeah. Okay, but in that case, whatever you are assuming, write it up. So I will say that for this assignment, think of it to be strictly increasing. Okay, all of you think of it as strictly increasing and do it. Sorry, somebody else was asking a question. I cut that person off because of answering.
Hello, sir. This is Neeraj.
Yeah, hi.
Sir, I was asking about direct proof. In slide 5b, we have a question like prove that root 3 is not rational.
Prove that root 3 is not rational. 5b. Yeah, yes, right. Yeah. Prove root 3 is not rational. Right.
Sir, so actually we are taking root. Suppose we are applying a direct proof. Sir, I mean, I have a question in general. Then, how can we say that our proof is, I mean, up to the mark if we are going with a direct proof? For example, suppose we are proving that root 3 is irrational.
Yeah.
We can say that anything inside a root can found out to be rational only when after the prime factorization, everyone has power as even.
Yeah, you are right. That is, I mean, it is not 100. This is not a proof, okay?
Yes,
Right.
sir.
So that is like, I mean, I understand whatever you are saying is correct, okay?
Yes,
but that is not giving a complete proof of it.
Okay.
Okay, I mean, like technically, it's not a complete proof. Okay.
Okay,
So
sir. I wanted to ask, like, suppose we are going with a direct proof. So how can we say that? I mean, this statement is okay to take, and this is not.
see, again, I mean, it's like all about it's there's no particular thumb rule, right? Like when you write in the middle of a place, you say that, oh, let me lay 100 plus 500 equals to 600. Do I ask you to go and prove it?
No, sir.
No, right? So that is because you kind of know that, oh, this is a kind of an easy thing to prove, or this is obvious, right?
Yes, sir.
So this is something that you have to kind of yeah, I mean, that you will get to know. So don't worry. So I mean, in the exams, none of them things will come out. Will be such kind of weird things will not be there, right?
Okay.
But your goal is always that. I mean, this is a general philosophy. Remember that whenever you are presenting something, it depends upon whom you are presenting it to. You have to understand that. Okay.
Okay,
If
sir.
you are trying to prove that square root some number, square root of n is irrational to me, okay,
Yes, sir.
it's perfectly fine to. I mean, if you are talking about research and all, you can say that, oh, n is these are the prime factors, and the prime factors don't have a even power, right? And I'll buy that. But if you have to prove it to a child, then that is not how should prove it, right? To a class 10 student or something.
Yes, sir.
Okay, so here what so see, again, remember that, I mean, this is something that I think you guys get confused a bit here. The goal of you to write a proof is not to pain you guys. Okay, that is not what we are want today. We're not that we are like, oh, the writing the proof is important. Yes, giving a formal proof is important. Okay, we are just want to ensure that you know what the formal proof is. Okay. So, I mean, if I say that, oh, prove that square root 3 plus square root 5 is irrational, right?
Yes,
How will you prove it? Direct proof or non-direct proof?
We'll assume it is rational and then like try to come up with a contradiction.
Exactly. So you will prove it, right? You give a proof of it, right? It is not like, I mean, so I can also say that, oh, it is a sum of square root of two prime numbers, and that is irrational, because I know that statement, and so when discussing, I can tell that, right? So when I ask you to prove this statement, it's not like I am just, I mean, your important thing is to kind of assume something. I mean, not assume. I mean, try to convince me and yourself that you actually know how to prove it.
So can't we directly use the statement like this, right? Since 3 is not a perfect square, therefore it is irrational.
Okay, and then 5 is not a perfect square, then therefore it is irrational, and therefore sum of the two irrationals will be irrational. Is that what you are saying?
For 3 is not the root 3 is irrational for that only. Like, do we also need to prove this fact that perfect square is irrational or irrational? Do we also have to?
I don't understand what you mean by do you need to prove or something.
Like, suppose if the question is that root 3 is irrational or rational. So if for proving that, if I'm using this statement like root of a perfect square is always rational, then do we also have to go on to prove that?
I mean, was such a question like that in the exam, in the assignment? So then why are this question coming up? I am not going to ask you root 3 is irrational or not. But see again, it's like realize that it is about. So I can also say that it is sum of square root of 2 primes, which is irrational, right? So if I ask you, I mean, I don't understand. I mean, you are talking about asking about something about how to write a proof on something that I have not yet asked you about. Forget the writing of the proof. Can you prove for yourself the square root 3 is irrational? How will you prove? How to prove how or why is square root 3 irrational? Do you know the proof of it? So that is the reason what we are saying that, right? Because if you know the proof, fine, good. That means you know the proof.
Sir, because if square root 3 is rational, then 3 must not be prime then. It has two factors of root 3 and root 3.
I don't understand. This is not, I don't. So you start with, okay, so why is this one irrational? Let's start with this. Okay. How will you, so if I have to prove it to a class 10 student, how will you prove it?
Sir, 3 is prime, and if square root 3 is rational, say then 3 would have 3 factors, sir, root 3 and root 3. Both are rational, sir. 3 would not be prime, so this is a contradiction, sir.
Yeah. By contradiction, we can prove.
Oh, so you mean that it is only because of, so you have to either, so whatever you are saying, so in that case, you will not be able, your statement will not work for this one, is that right? So 10 is not a prime. How do you prove the square root 10 is irrational?
So splitting it into root 2 and root 5 and then applying the same.
Then applying what? So this is square root 2 into square root 5. You are saying that, oh, square root 2 is irrational. Square root 5 is irrational because these are like something that you know because they are prime. And therefore square root 10 is irrational. Is this what you are saying?
No, sir, this is not in general true.
Exactly. So that is the reason why I say that there is a proof is required. Okay. So there is a okay. So yes, this might be that for you square root 3 might be obvious that it is irrational. For you square root 5 might be also irrational, but for you square root 10 that it is irrational, it is obvious to you, but you don't have a proof. Okay, so that is exactly what we are trying to argue here. How do you give a formal proof?
Sir, here in this case, we can prove by contradiction, like assuming root 3 is rational. So it will be of something of the form root 3 equals to a by b, where GCD of a and b is 1. And then if we can show that the GCD is actually not 1, then by contradiction we can say that root 3 is not rational.
Exactly. So the formal way of proving it is by contradiction. Okay. So you can start with okay. So let square root 3 be equals to rational, means p by q, and therefore 3 equals to p square by q square, and then argue that this is not going to work. Okay. But this is not. I mean, for you it might be that this is an obvious statement. But what is an obvious statement and what is not an obvious statement, you have to be a bit careful here. Okay. So that's why when something has been asked to prove, it means that you are supposed to give a formal proof of it. Just a hand wavy argument is not good enough. Yes.
Proof by counter example is a valid proof technique.
It's a very much valid proof technique, but that is when there is a counter example. Okay, that's a very much of a valid proof technique. Okay, so maybe here I should kind of point out also, for people who are not comfortable with it, I was about to say, so till now, what all proofs have we seen to some level? We have proved some direct proofs or basically case studies, right? Or case studies. Now, what does case studies are? Case studies are basically you break it up into, you break the problem into finite number of problems. Break the problem into finite number of problems. Number of problems. Now, I mean, the reason I've used the word finite is very important because this is something that will come up very soon. Finite number of problems. So you break it up into, say, 5 problems, 3, 4 problems, and so on, and then prove each problem, prove each small problems individually. Right? So this is basically case study that you have done. Right? Now we have seen the other proof, which is a proof by contradiction. Now there are some other stuffs actually in this proof. I think in the assignment there is this thing called write the contrapositive. Now I don't know whether you know, how many of you know this meaning of contrapositive also. Okay, so it is kind of I mean, I will be uploading another set of slides and you will see that contrapositive there. It's basically same as contradiction. Okay, so basic idea is that if you are trying to prove A implies B, contradiction is that not B and A, you will end up producing some stupid statement, right? Give a false statement. And what is the contrapositive? You have to prove A implies B is same as, so this is same as, right? It is like not B implies not A. Okay. Now, in some sense, again, I mean, all of them are same, right? I mean, both this statement, both this one and this one are equivalent statement to A implies B. So you might say, oh, this is same as this. Yes, of course, they are all same. But sometimes proving a statement like this is slightly easier. Sometimes proving a statement like this is sometimes easier. Proving a sentence like this is sometimes easier. Okay. Now this is basically direct proof, contradiction, and contrapositive. Now these are the 3 things that has been kind of looked into so far. Now in the assignments, there are these problems of say proof or disproof, right? So all of them is basically saying that proof. Proof means what? It means proof of A implies B. Okay. Now if I how about if I say that proof of, so all the above statement is of this form, right? Proof of A implies B, all of these things. Now what happens if I ask you to either disprove, if I ask you to disprove A implies B, or the same way is that proof that A implies B is false. Okay, or A implies B implies false, something like that, right? So what does it mean? See, if A implies B implies false, meaning it can only happen if this A implies B is false, right? So this is basically saying the proof that A implies B is not true. How do you prove it? If you want to prove that A implies B implies false, okay, then one way of doing it, yeah, is to give a counter example. Counter example meaning you just say, okay, see, A implies B says that, say, if you remember this whole thing, that we had this initial part that prove or disprove, say n square minus 41n plus, I think 41, right, is prime or something. I forgot what was the
n square minus n, sir. N square
minus n plus 41. Okay, yeah, right. Now, if I have to prove it, then I have to prove it for all n. But if I have to disprove it, that means I have to prove that this statement is false. This whole statement is false. Right? This whole statement is false. What does meaning by this whole statement is false?
Just come up with one example.
Right,
that can prove it.
But exactly. So that is one way of proving it. I mean, that is the right way of proving it. But in the sense of logic, okay. So this is false, meaning it's the negation of the statement is true. Right?
Yes, sir.
A statement is false, meaning the negation of the sentence is true, right? What is the negation of this statement? Negation of this? What is this?
There exists an n such that n square minus n plus 41 is not prime.
No, remember, I had talked about this one. Negation of for all x p of x is there exists x not of p of x. Okay, so that means the negation of this statement is there exists n and then this statement, right? You have to take the negation of that. The n square minus n plus 41 is not prime. How do you prove it? So this is the negation of the statement. So if I have to disprove this sentence, I have to prove the negation of this sentence, which means it is this one. I have to prove this sentence. And how do I prove this sentence? By the sentence itself is proof that there exists an n, right? So prove this sentence, this statement. The most natural way of proving it, actually speaking, is by demonstrating an n such that n square minus n plus 41 is not prime. Okay, so this particular thing, this kind of a statement, or an example that will show you that this statement is false, okay, this is called a counter example. This is what is called a counter example. Now be a bit careful with this counter example, okay? Because if I ask you this following statement, say let me give you a completely different statement. Okay. There exists, or say if I tell you to disprove, there exists n such that n square minus n plus 41. This is not right. This is not the right one. There exists n such that n square is congruent to 2 mod 8. So of course you know that this statement is false, right? This sentence is false. How will you disprove this sentence? Hello?
Sir, I will provide a example, counter example. For n equal to 1, it will not hold true. Then it is a counter example.
Okay, what do other people say?
Sir, for all n, n square not congruent to 2 mod 8.
Sir, for all n, n square minus 2 is not divisible by it.
Right. So think about this one. Okay. So you have to disprove this. That means you have to do the opposite of this. Okay. What is the opposite of this? So negation of this is what? For all n, n square is not congruent to 2 mod 8. Now, do you think this statement can be proved using an example?
No, sir.
No.
Counter example.
No, it is not. It cannot be proved using a counter.
No, sir.
You see,
Yes, sir.
earlier it worked because the negation of this sentence had a there exist. When you're trying to prove a there exists sentence, you can use a counter example. When the negation has a for all, then a counter example will not give you anything. Okay? So for example, here in the counter example, you will end up proving that, oh, say I will give you an n such that n square minus is not equal to 2 mod 8. Very good. I understand that. But I didn't say that for all n it happens. Right? So a counter example in this particular problem is not a solution. Okay. So you have to always remember what you want to prove. If you have to prove or disprove a sentence like this, disproving a sentence like this is very easy. Why? Because the negation of the sentence has a there exist, which means that all you have to show is there exists, you have to demonstrate this happens. So which means that this can be done using a counter example. But if the actual statement has a there exists itself in it, then the negation has a for all, right? And in the for all sentence cannot be proved using one example. So maybe if I have to kind of give you a high level thumb rule, this is it. Okay, that if the problem is prove there exists x p of x, okay, this is a bit of a easy. Why? Why? You have to just demonstrate an example. An example. Okay. But if you have to prove that for all x q of x or for all y q of y, then this is hard. Okay. But again, if you have to disprove them, okay, if you have to prove them they are not true, then which one becomes easy?
The second one, sir.
The second one becomes easy. The second one, when you take negation, it will become there exist. And the first one, when you take negation, will become for all. So first one becomes hard then. Okay. So don't blindly just go and give a counter example or something. Counter example is a valid statement. Counter example is all saying that you have to disprove something of the form there exists for all, which means that you have to prove that there exists x, and that becomes a counter example. Okay. Is it fine? Hello.
Yes, sir.
Yes, sir.
Sir, to prove by the counter examples, then we should go for like n equal to 1, n equal to 2, like so on. Or there is a method for.
Oh no, there is no method for that. There is no method for counter example.
So we have to go on by taking 1, 2, 3, 4 like that.
I mean, it's all about your smartness. Okay. I mean, see, now you are doing numbers and all, then there is 1, 2, 3, 4. Very soon we will be talking about graphs. What do you mean 1, 2, 3, 4? Then graphs.
Yes.
Okay, so it's all about your smartness. How clever are you to find a counter example?
Okay.
Yeah, somebody else was saying something.
Sir, in the above example, direct proof is the best way to prove this one. Yeah, this one.
No, yeah, this will either direct proof or contradiction, maybe.
Okay.
Yeah. So the example is not the one that will give you anything here.
Mhm.
We will also talk about it. Okay, for this particular problem, maybe the direct proof is what I will basically go for. Okay, but there is nothing called a base thing or worse thing. Okay, like I will give you an example of this thing. So you have seen the primes are infinity, right?
Yes.
Now, what is the proof of it? Now, the most classical proof of it is basically proof by contradiction, right? You say that, oh, this is not true, and then you end up say that, okay, if so, classical or easiest proof, or the first proof, let's say, is by contradiction, right? And I think this has been done in the slides, right? So basically, if, or sorry, let primes be finite, let primes be finite, then you have this P1 to Pn be the primes. And then you end up proving that, oh, okay, what happens if I take P1 dot P2 till Pn plus 1 and prove that this one is not divisible by any of the primes. And from that you kind of, so let this be Q. So Q prove that Q is not divisible by P1 comma till Pn, which implies Q must be also be prime. And we know that Q is bigger than P of n, which means that I started with an assumption that there are n primes. The largest of them was Pn, and you ended up producing another prime which is bigger than Pn, and that being in that case that has to be a prime. Right? So this is the most natural and simple and beautiful proof that one can think of for this problem. But believe me, this problem, if you want to go, so there is a book called Proofs from the Book. Okay, people who are interested in it, I recommend you to go and take a look at this book. Okay, this book is a classic in the sense that it is like it concept to be like yeah, it has a certain problems, it has a very nice solutions and all have been given here. And in this book, it starts with giving 28 different proofs of primes are infinity. 28 different proofs. Okay, and some of them are using so different techniques and all that like hard to imagine. Okay, so all I'm saying is that there's nothing like what is the right way to prove it. There are n number of ways to prove it. One might want a direct proof, one might use a contradiction, one might use something completely different ideas. Okay, at the end of the day, all that we are trying to say in this particular course is that when people want a formal proof, you should ensure that you write it, or you should go about it formally. There are various directions to take. We are not going to say that, oh, this one you have to use direct proof, for this one you have to use proof by contradiction. Nothing like that. But whatever you do, you should do it formally. Okay, and that is all that we are supposed to kind of teach you guys. Yes. Okay, so there is no unique proof. So if somebody comes up with a different proof of it, as long as it's formal, as long as it is correct, okay, it's good enough.
Sir, may I tell you something?
Yeah.
Actually, there are 6 proofs given in the book. 6.
Okay, fine. Yeah.
It is by Martin Aigner, I think. Martin Aigner.
Yes, I mean, I don't remember what how many proofs and all, but there are quite a number of proofs there.
There are 6 proofs.
Yeah. So any other question? Many of you told that you had some questions about this sector of the slide 5B or something.
Sir, I have a question for you.
Yeah.
Contrapositive proofs are not clear to me entirely.
Okay, what do you mean not clear to you?
Because I'm not much used to this term before. I tried to convince myself, but I couldn't.
Okay, so I mean basically, so okay. So what is a contradiction? Okay, so contradiction is again, as I told you, that so you have to prove A implies B, right? This is the main thing that we have to prove.
Okay.
No, hold on. So in A implies B, one way, the contradiction. So you have many ways of doing it, right? So the contradiction, what do you do? In contradiction, you try to prove that you start with assuming that not B is true, okay, and you sometimes assume that, and you assume A is true, right? Not B is true and A is true, and you can go ahead and do a lot of reduction and all those things, and at the end of the day, you end up getting a contradiction. What does it mean? It means a false statement, a statement that we know is false. Okay. I mean that sentence can be not of A, and that will imply that says A is true and not A is true, and therefore something, or it can be something completely different. Okay. So for example, I want to prove that yeah, so like in the primes is infinity. I started with this assumption. Yeah. Hello. Okay. Okay. So I started with this assumption. Okay. It's not assumption. I started with the assumption that primes are finite, and then we got a contradiction. What is the contradiction?
You can say that our original statement was true.
Which one? Which one are you talking?
To prove by contradiction.
Not necessarily. Not necessarily. You not say the original sentence is true. Like for example, here, what is the contradiction?
What I'm saying that we want to prove that A implies B is true or not,
yes.
And by applying the theorems and like by applying the steps, we come up there to know that its negation is false.
Which negation?
So,
no. Hold on.
It's A implies B's negation is false. If we can know this, then we can say that original statement is true. So is it the proof by contradiction?
No, A implies B negation is not false. In contradiction, this is exactly what I'm saying. That A implies B. You assume that B is false. Okay, or sorry, that means not B is true. Let's say that not B is true, and then you assume A, okay, not B and A, and then you end up saying something false. For example, look at this statement, right? So we started with B. So what is okay? Let me maybe go over this prime says in P a bit more. This thing again. Okay, so we have to prove that primes are infinite. Okay, what is the assumption? What is the deduction? Now see again, as I told you, there is no assumption as particularly as we stated, but it basically means that assuming, I mean, from all these truth statements, okay, or you can think of all known true statements, can we imply P primes is infinity? Okay, so this is has been kind of kept hidden, like or all the other axioms and all. So the proof by contradiction, this is my B. So what is not B? So not B is primes are finite. Okay, so I assume primes are finite. Okay, so I assume primes are finite. So let the primes be P1 to Pn. Okay. And then I'm assuming lots of other statements, right? So lots and lots of other statements are there. For example, right? Then I am looking at Q equals to P1 to Pn times Pn plus 1. And I have to prove, okay? Then we show that say Pi does not divide Q. Right. So there are lots and lots of these. So this will require its own set of assumptions and all. And at the end of the day, what we end up proving? We will end up proving that so Q must be prime, and of course we also know that Q is bigger than Pn. So what is it contradicting? It is contradicting whatever we are starting with, right here. So here we get a contradiction to whatever we have assumed. Sometimes it might be something completely different. By doing all of this, we might end up proving that 3 equals to 2. Okay, or sometimes we will end up proving that some other stuff gets is violated. Okay, so basic idea is that you assume not of B and you assume the initial conditions that are there and you end up getting a false statement out of this. So this is contradiction. Is it clear?
Here A is another statement.
A is another statement. So say for example, let me just start with this. I mean, say if A is if N is okay, let's start with this. If G is a connected graph, then G has greater than equal to n minus 1 edges. So this is the statement. I am asking you to say prove it. Okay. So here what is A, what is B? So A is basically what? So this is A. G is a connected graph. This is A. Okay. And G has n minus 1 base. This is B. Okay. So we have the statement that A implies B. Right. So what do we have to prove? So by contradiction, so not by contradiction, for proving by contradiction, proof by contradiction, let G has less than n minus 1 edges. So what are we assuming? So we have the fact that G has less than n minus 1 edges and we are assuming that G is connected. Now somehow or other you have to, from here you have to produce something false statement. Okay, if you can produce a false statement from these two, then we get a say that okay, see we have assumed something and we have ended up proving false. So which means that not B, this means that not B and A is false, implies false. Okay, and this is exactly same as A implies B. Okay, so this is basically the proof by contradiction. Okay, now proof by contradiction is a bit of a generic term. A special case is the proof by contrapositive. So, okay, so before I go into contrapositive, is this clear? Should I repeat again something?
Sir, means that statement will be G is connected graph and has less than n-1 edges.
Yes.
This should be false.
This should be false.
Okay.
Okay, so that is the contradiction statement. Okay, so always try to identify what is it that you are trying to prove and what is it trying to assume. Okay.
Sir, if we have a number n such that n is greater than equals to 2, and we have a condition that n square greater than z.
Yeah.
So can we say that n is also greater than z?
N is greater than 2 and n squared is greater than z. Then
can we deduce that n is also greater
okay,
than
let's see.
z?
So this is what you are saying. So can you say n is greater than z? Greater than or greater than equal to?
Yeah, greater than equal to.
Okay, and what this is greater than or greater than equal to this one? N greater than 2 or not?
Greater than equal to 2.
Okay, so this is a statement. Okay, okay, let's see. So your friend has given us a problem here. Okay, so there are again many ways of proving it. But if you want to try to prove it by, if you try to prove by contradiction, then what will we end up proving? Okay, so let n be less than z. See, note that this is my B and this is my A. Now, A has two parts by the way. Okay, so at this point, I have assumed that not of B, meaning n is greater than z. So what all things we are there? So I have one n is less than z. I have got n square is more than z, and n is more than or equal to 2. From these three things, can I end up producing a contradiction? Right? So this would be a proof by contradiction. Right? So now, okay, let's see. So this basically means that n square is less than z square. Right? So we have that z is less than n square is less than z square, and n is bigger than 2. Now what is n? Is n
Hello, sir.
Yeah, hello.
Sir, we have a contradiction, right? N square is less than z square. Is a
n square is less than z square. Oh, but n square. Oh, n square is less than more than z. That's what's told. Right? Sorry, I made a mistake. Yeah. N square is more than z, and n is sorry. Right? You are perfect. I made a horrible mistake.
Sir,
No,
we can't square like this, na?
no. N square is more than z, and n square is less than z square. See, yes, sorry. So we have this one, which is z. So why do we have a contradiction?
Yes, sir, got it.
No, in fact, this statement is not true. So it is very much possible that so this is not necessary. The case. Okay, for example, say n equals to 3, okay, and z equals to 8. No, sorry, z is not
Sir, sir, what is Z here?
There is some number, he's saying.
Sir, so if n is greater than Z and Z is, we don't know about Z, then can we square like this in case of inequality? N square is less than Z square.
No, this we can because of this form, because n is bigger than z and n is bigger than 2, right? So n is a positive number. Okay, since n is a positive number, therefore you can multiply. You can talk about n square is bigger than less than z square.
But Z we don't know, na, sir, about Z. We know about N. It is
Oh,
written.
That is positive. Says that is positive.
Oh, okay, so you're saying that is positive. That you are right with whatever you guys told.
Yes, sir. Well, we don't know about that.
Sir, if we choose N as 2 and Z as 3,
No, see, z has to be positive. Z has to be positive because n is, we have assumed n is bigger than.
Yeah, Z is greater than, yes.
So that means n is bigger than 2, so z must be greater than 2 also. Yeah, so this one, so n equals to 3, z equals to 10. So this,
sir, I didn't understand that why that n less than z, then n square less than z square.
yeah.
What means what we are claiming about z?
We are not claiming anything about z. Question is that, so maybe if this is how, okay, so maybe this is how we should maybe formulate it. Okay, so this maybe it was slightly less well clear from. So there are two ways that you can think of it. Okay, so I think this is what he meant. For all z and for all n, okay, n is bigger than or equal to 2 and n square is bigger than or equal to z implies n is bigger than or equal to z. Okay, so this is what I think he meant. Okay, and I think this statement is not true. I mean, this problem is not true. I mean, this whatever this is, this thing is not true. Why? Because think of n equals to 3 and z equals to 10. Sorry, not 10. N square is greater than z, right? Sorry, and z equals to 8. Right. So this is not true. So by the way, so okay, so who gave the problem?
This is Soham.
Yeah, yeah.
Actually, I had a doubt in slide 5A.
Slide 5A. Okay.
There was a problem that this problem 2b cube greater than equals to 3b plus 2.
Right.
So there we are deducing that b cube is greater than equals to b square. Then we are saying that 2b square also greater than equals to 3b plus 2. So can we deduce this in this way?
Okay. So b cube is bigger than equal to b square. You have a problem with this? No, right?
In the next slide, we are saying that 2b square is also greater than equals to 3b plus 2. Can we write this statement? 2b square also greater than 3b plus 2.
I think because 2b square was proved to be earlier is bigger than 3b plus 2. Right? Previously, we had already proved this thing, if I'm not wrong. Yeah. That's, sorry. 2b square bigger than 3b plus 2. Sorry, what was it written? Maybe 1 second. Oh no, sorry. So sorry, I didn't. So this is not. So this should have been. Oh, so don't look at it in this way. Okay, I think this sentence this is not a full stop here. That should not be. So this is what was being told. Yeah. So b cube is bigger than b square. Fine. So look at this one. If I so 2b square is bigger than 3b plus 2 implies that 2b cube bigger than 3b plus 2. Okay, so it's the reverse direction at this. So basically the idea is that because of this one, you can therefore
Sir, basically the reverse is also true. Like 2b squared is greater than 3b plus 2 for b greater than equal
yeah,
to
exactly. So that's the thing. So here their main idea is that you have to prove 2b cube is bigger than 3b plus 2, but you can relax it by replacing this 2b cube to 2b square. And that is easier to prove.
How can we relax it, like because b cube is greater than equals to b square, so we are
I'm making the problem harder. I'm making the problem harder.
yes, the problem becomes harder.
Yes, but harder problems are sometimes easier to solve. That's the main idea of this thing.
Yeah, okay, so I got it. Yeah.
Okay, sometimes harder problems are easier to solve than easier problems.
Sir, I didn't get that. That how we are saying that, like how we are then saying that 2b square is greater than equal to 3b plus 2.
No, I'm not saying that. I'm just so look at this sentence here. These two sentences together. This sentence is not saying that 2b square is bigger than 3b plus 2. What it's saying is that if 2b square is bigger than 3b plus 2, then we have 2b cube is bigger than 3b plus 2.
Yeah, it's fine.
Yeah, that's all it is saying. So if you have to prove this statement, it is enough to prove this statement.
Okay.
Yes, I got it. I misunderstood that one.
Okay. So any other problems, comments on this in these two things?
Sir, when we have to negate a statement, can we directly just write the final
Negation?
statement? Yeah, negation.
I mean, yeah, you can do it. I mean, see again, I mean, what you write, if you jump steps and all, it's not my issue, okay?
Okay.
I am more worried about you get it right.
Okay.
All of these things is being done so that you know how to get it right, this sentence. Okay, just write down the negation of the sentence and that is good enough. But when you are negating it, think about it in your head that this is how it should be done. Okay, so that you get the right negation. Yeah. Yeah. Yes. Some other problems, doubts, questions?
The contradiction I understand. Contrapositive.
Ah, right. Sorry. I forgot. I got stuck with this. Okay, so contrapositive is a special case of contradiction you can think of. Okay, contrapositive. Okay, so as I told you, in contradiction, so you have to prove A implies B. Okay, this is same as saying that not B implies not A. Okay. Now, no, see, if you prove not B implies not A, from there you can also see that not B and A is false. Right? It's kind of easy to see. But this is this is called the contrapositive sentence. So this one and this one are contrapositive of each other. Okay. So sometimes writing it in this way, right, just trying to prove this statement can be much more useful. So let's see.
If for all is not given, then does it imply for all a statement is true? Like in assignment, we have a question. Finite sum of distinct irrational numbers can never be a rational number. So is it should we assume that it is for all, like for all x, y, z, if x,
What do you
x,
think? What do you think should it be?
it should be for all.
It should be for all. See, in the English sense, it is written in English, right? And in English language, this is kind of the implicit thing here. Right? If somebody says that, prove that product of, or prove that sum of two even numbers is even, is it like somebody has to tell you, prove that for all two even numbers the sum is even? Nobody will say it like that, right? In English, it will prove that sum of two even numbers is even. It mathematically translates to for all x and y, if x and y are even, x plus y is also even. Right? Similarly here, it says that prove that, or prove or disprove that sum of finitely many rational numbers or irrational numbers is irrational. Okay? And this is exactly same as, I mean, is exactly or mathematically same as saying that proves that for all irrational numbers x r1 to rk for any finite k, r1 plus r2 till rk is irrational. Okay. So this is just something, a translation from the English language to the mathematical language. Some more questions, doubts? All doubts have been cleared?
Hello, sir.
Yeah.
Sir, is it fine if we don't use the latest templates which use pointers?
You can use any template. I am not worried about templates.
Actually, sir, what I'm doing is I'm writing a solution on Google Doc and using latex for equation part. Is it fine?
I mean, and how will you bring it back? Yeah.
Yeah, I will download and then send you. I will download that file and then send you.
I mean, I don't understand what you are doing, because the equation part is the hardest thing to write in the LaTeX. The rest of them are kind of trivial.
Yes, sir.
So, I mean, you are basically saying that I will not write the English thing in LaTeX, I will write it in.
Sir, I'm writing English part in normal, and for equation I'm using latex.
I don't understand, honestly speaking.
Okay, sir. I will send you.
Send me and then I will see.
Okay,
okay. But it is actually pretty simple. I mean, just in English part, you don't have to write anything. Just copy and paste it, and it will kind of compile.
Okay, sir.
You just copy and paste and it will compile there. Within the begin document, end document, put the English part.
Okay.
Sir, if a statement cannot be proven by induction method, then it is not true, sir. Can we suppose, sir, in that question, n into n minus 1 plus 41, Pn statement would be this, and Pn plus 1 statement we find, then it would be n into n minus 1 plus 41 plus 2n. Then n into n minus 1 is prime we have assumed in Pn statement, and we cannot say anything about 2n. So we can say, can we say that it cannot be proven, so it is false?
No.
In
Remember,
general.
remember that in general, this is how it is important. This is something very good point that you have raised. Okay, and arguing that, see, I have tried to prove it this way and have failed is not a proof that it is not true.
Yes, sir.
That is something very, very, very important thing that you should always remember. Okay, and possibly this is the, I mean, you have kind of captured this, all the things that I wanted to say in one sentence in some sense. Okay, that we want formal proof. Okay, this has two parts of it. One is that if you say something, you should be able to prove it. And secondly, if you want to disprove something, you have to disprove it. Saying that things like, oh, see, I have tried to prove it using the best of the techniques that I know of, and I've not been able to do it, is not a proof. It's not a proof of anything.
Yes, sir.
Okay. So if you have to disprove something, you have to, I mean, it's a disprovement. Either you have to give a counterexample or you have to give a proof depending on the problem, but you have to give it. Okay. Yeah. So by the way, all of you, of course, know induction thing a little bit, and I should kind of say it here that, so till now, what did we do? We were talking about the direct proofs, right? Think of the direct proofs. In the direct proofs, we kind of say that, okay, we have A implies B is what we have to prove, and A can be written as maybe a C1 or C2 or C3 till or C some K, right? And so in that case, A implies B is same as saying C1 implies B and C2 implies B and like this till CK implies B, right? So you have kind of split up the problems into K small chunks and solve each of the problem individually. So this is what we have done for direct proofs. But problem is that this all can be done if the number of them is just some K, which is a small number K. The K can be 100, which means that you have to prove this, use this technique, you have to apply this, you have to prove for 100 different small problems. Very good. But what happens if you cannot split it up into just a finite number of them? If a particular A can only be split up into C1 or C2 or and goes on till Cn, and it goes on for infinity, then it is not necessary, or it is impossible to prove it for all Ci implies B, because there are infinite number of them, right? So at that time, we have to prove it in some nice way. Okay, so you have to prove it that for all I, Ci implies B is what we have to prove, right? Now, for proving this sentence is basically it's a direct proof, only we have to kind of apply, because we are splitting up the assumptions into lots and lots of small parts. Then we have, this is when we use induction. Okay, and I will in the two set of slides that I will be upload today, okay, you will be seeing the first basic steps of induction. The basic proof. Now, of course, you all have seen induction in your life. All of you, I'm 100% sure. In your high school, you have seen induction, right? Like, how do you prove that sum of 1 to n is n into n plus 1 by 2 or something like that? So what I want you guys to is to go over it, kind of maybe recall all those induction stuff. Okay, we will do a few examples of that form using inductions. Inductions can be pretty tricky many times, but more importantly, we will be doing things which are induction on combinatorial objects, and this will be kind of important. If you remember this handshaking problem that was there, we will be using induction for the handshaking problem to prove the handshaking problem. Okay, so I will be uploading two set of slides. One will be on contrapositive and counter example. That will be kind of easy to follow. And the next one will be induction, which is also easy, but the main idea is that where it kind of differs from direct proof is that we have to kind of break up the assumptions into infinite number of them. And at that time, simple analysis, simple propositional logic will not be able to tell you that induction works. So what we will need is something called an induction hypothesis, or and that is something that is almost, you can think of an axiom in the world of mathematics. Okay. Yeah. So any other questions about this 5A, 5B that you have? No questions? All of you are very comfortable with all of them? Okay. So let me ask you one more question. What about next class? Next class is on 25th. Do we have class on 25th or not? Do you have any idea? Do you guys want class on 25th? How many of you don't want class on 25th? This is not going to happen, but you should unmute yourself and say something, either yes or no.
Sir, no.
You don't want class on 25th?
Yes, sir.
Right. Okay, very good. When I ask a question, I really expect you guys, all of you, to unmute and say yes or no. Okay, without any response from your side, it's very hard to communicate. This is not a normal class. Right?
Sir, I think it's in chat.
Okay, it's in chat. Okay, very good. So then in chat. Okay, so many people are saying no. So let's not have it any class on 25th. I will be uploading therefore the I will be
Sir, can you sir, can you upload this slide?
I will upload this slide. And which slides?
That you have teachers.
Yeah, I will do that. I have done that for the last class also. In the web page, everything is there. Okay, so I will be uploading the slides. This class notes. I will also be uploading the two sets of slides. Okay, so the next class will be next Tuesday. So you have a lot of time in your hand. By the time, I will really expect all of you to have gone over all the 4 slides that have been uploaded very thoroughly. Okay, if you have, we will, once you go over it on Tuesday, we will discuss those, discuss any doubts that you guys have on induction and this proofs of way. And if not, then we will really jump into the most interesting part of our basically most important part of our course, or interesting part of our course, where we will start doing problems using induction or actual problems in various combinatorial objects. Okay. Any other comments, questions?
Assignment 1 can be submitted anytime on Thursday, right?
Yeah. Assignment can be submitted anytime on Thursday. Okay, so if you don't have any other questions, let me stop here now. Fine. Okay, so I will talk to you. We'll see you on Tuesday. Okay, and please follow my web page, and web page will have all of these uploads.
Thank you, sir.
Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.